This is probably the cruelest joke ever played. As you can tell from my name, O'Riordan, I'm an Irishman. And everybody is drinking except me, because I'm the last man to present. No, it's very cruel. What we're going to try and do here is we're going to do, I work on the Bluemix team. I work for an area of IBM called Ecosystem Development. And we're going to have a look at this thing called Internet of Things, a live demo. I'll go through the agenda afterwards. So just a little bit about myself, right? Who I am, right? I always wanted to be a professional snowboarder, but there was no snow in Ireland. I wanted to be a professional soccer player, but I was rubbish. So I decided to become a software engineer. And here I am today, boring you with Bluemix and Internet of Things and IBM stuff. Here's just a quick agenda as to what I want to do. A quick intro on IBM, Bluemix and IoT. It will be very, very short. I'm not going to go into the history of IBM. Describe the IoT project that I'm working on. Go through the demo and then examine some of the code, right, on this demo. So the first thing, IBM is going through a massive change. If I was to speak to my father and say, IBM, what does he think IBM does? He would describe it as this big company that sells massive big boxes to banks and insurance companies. And he pretty much has it right. That's what IBM's main business was, selling enterprise software to insurance companies and banks. And IBM is going through a massive change. The game has changed. You know, I've worked for IBM 10 years. I never actually thought I would see the day when IBM would be selling its enterprise software on a pay-as-you-go on a cloud. I never thought I would see that day. But the day has arrived. It's called Bluemix. It's called Software. We're taking our whole enterprise catalog of software, all of that software that runs on banks, runs for insurance companies, all of that enterprise software, and we're making it available through this platform called Bluemix. Okay. Bluemix, it's our next generation platform as a service. So things like API economy, what does that mean? A developer wants to build an application. He wants to write that application in Java, Node.js, PHP. What he wants are a set of services that he can program against. So he wants a Hadoop engine. He wants a NoSQL database. The developer doesn't want to spend his time trying to set up all of the infrastructure to have that database running. So with PaaS and with this API economy, what we're saying is you write your application, you select the services which will have REST interfaces on them. You say, I want that service. You see the price as to how much that service is going to cost when it goes into production. There's a freemium version of it for you to write and test your code. So he has the full catalog of IBM enterprise software as well as third-party software from our partners available to him to code and develop against. It's built on software, and that's really, really important. We tried our own infrastructure as a service cloud, and I don't think really, to be honest, we were that serious about it. So we went out and we acquired Software, and Software have the best infrastructure cloud available today. What Software specialize in is that high-speed private network between the different data centers, the ability to provision not only virtual machines, but bare metal machines. Software is winning against AWS, Amazon, and all of the others. And this is the engine underneath Bluemix. When you push your code, when it gets wrapped with a build pack, it's getting pushed up onto Software. So it's important. Internet of Things, what is this buzz around Internet of Things? Well, for me, it's traditionally anything connected to the internet was maybe a mobile phone and a computer. But because producing silicon has become so cheap, your fridge, the engine management system in your car, pretty much any device you see, we can put a piece of silicon in it, we can get it to connect to the internet. And that's all great. But all of this data, what do we do with all of this data? So it's connecting all of these devices, there's massive volumes of data. So how do you extract insight and intelligence from this data? And this is where I think IBM have something to offer. We have spent years acquiring companies, building up knowledge and expertise in helping analyze this big data problem. And that for me is some, my version of what Internet of Things is. Okay, so describe the internet project I'm working on. So my management team, they came to me and they said, okay, we want you to build a sexy demo. Okay, so I said, okay. So I'm turning 50 next year. I know that's hard to imagine. So I'm turning 50 next year, so I said, okay, let me try and build a demo on analyzing when I'm going to get a heart attack. See, is that possible? I live a fairly hectic lifestyle. So I wanted to see, could I build a heart rate monitor that would analyze my heart and thousands of hearts, send that data to an Internet of Things service, and put a whole load of analytics behind it to see, could I predict my health to see when I would get a heart attack. And that's the basis of the demo. Now, we're still working on it. I still haven't got the heart attack. Okay, so the demo is a bit like that. So here we have Dan. His heart is still going. There's a Bluetooth device connected with 3 leads connected to the heart. Now, we're working with a partner in the US called MedTel24. And MedTel24, their business model is, you're not feeling so good, you go into your doctor. The doctor, he puts what they call a Holter monitor on you, which basically records your heart for 24 hours. You then go back, the doctor plugs it in, he looks at the ECG, and he tells you whether you're going to live or die. He looks for abnormalities on the ECG. So we teamed up with this company, and the Bluetooth, so this is a Bluetooth device monitoring the heart. And what we decided to add to it is using an Android phone. So we wrote an application on the Android phone with some algorithms on the phone itself. Now, in heart rate analysis, the thing to detect is this, what we call a QRS signal. That's the typical signal. And that's actually quite difficult to detect. And there are open source algorithms. One is called the Pan-Tompkins algorithm to detect if you have a correct QRS signal. Because sometimes older people have something that looks like a QRS signal, but it isn't. So we have some algorithms on the phone to kind of detect when you have a correct heartbeat. And detecting a correct heartbeat will be important in the analytics later on. So here we have the cloud, IBM. So this is where all of these, we envision MedTel24, who have thousands and thousands of patients connected, sending, each time they have a heartbeat, sending that data to a cloud to be analyzed. Now, MedTel24 are quite a successful little company, but there is no way could they build the infrastructure to support, tens of thousands of devices sending all of this information. So this is why they have come to IBM and asked us for help. Because infrastructure we have, software, that infrastructure cloud we have, and we have the analytics. So this is the IBM part. Internet of Things, so basically this is a whole load of infrastructure. It's message queue infrastructure sitting on a software data site that is surfaced through Bluemix as one of those services. So the transport protocol I'm using is, I have a small MQTT client, a jar file we'll show, that's basically sending, each time there's a heartbeat, is taking some information and sending that to the back-end Internet of Things service. So the back-end application is something that we call Node-RED. Node-RED is an open source project developed by my colleagues in Horsley. And it basically is a wiring tool for Internet of Things. If you think of like a message broker, it's a bit like that for Internet of Things. The ability to have on the front end your IoT receiver detecting and looking at a particular MQTT topic and then routing those messages to maybe different databases depending on the nodes. And I'll show you this later. So what I decided to use was something called Cloudant. Now, the world has changed. Originally, when I was building applications, we were writing standard client-server applications, where the first thing and the most difficult thing for us was to define the structure of the database. We spent weeks and months defining the schema for the database. And with the advent of mobile and this NoSQL became popular, which was basically, take the data, put it into a JSON document format, and just put it into the database. We'll worry about it later. We'll build intelligence later. And Cloudant are the biggest database as a service company today, and IBM acquired them. And Cloudant is cool. I mean, I was a real SQL man, a traditional, until I saw what Cloudant were doing. I mean, they've data centers distributed all over the world. So I decided to use the Cloudant service to basically store all of the JSON messages that were coming in. So I'm using it as a big bucket. So then I experimented. Now, in this example, we changed it because in this example, we're connecting to Hadoop. This is based on IBM Big Insights. It's our Hadoop engine. But I'm also sending the data or syncing the data with a database called DashDB. And DashDB was previously DB2 Blue. I mean, I hate the name DashDB. I mean, it's like a child's toy. But DashDB is our data warehouse in the cloud. And it's based on DB2. It's based on technology, columnar tables and stuff. So it's a database for analytics. It's not in this slide, but we'll show you later. So the analytics I'm using is based on I've written it. It's based on a statistical programming language called R. Has anyone program in R? Because I need to talk to them later. Okay, great. I sound like an American now. I'm using this word cool a lot, right? But R is a very powerful language for doing data analytics and statistical programming. So this photo here is for SPSS. SPSS is our predictive analytics tool. It's not one of the services available in Bluemix yet, but it's coming very, very, very soon. There's a very simple reason why I prefer R, because I found an open source package called HRV, heart rate variability, which did some of the analytics for me. I mean, the last thing I wanted to do was learn R, but I'm a very lazy person. So I found this open source package developed by some of the universities in Spain called HRV. So that's basically the package I'm using. So as simple as that. I'll show you. I'm not actually using push notification in this demo. I'm using SMS, using a service in Bluemix called Twilio, and I'll demo that later. Okay. So let's have a look at the demo. So so here's the code. So I'm running it in a simulator. I don't have the Bluetooth device attached to me because it would probably be going very quickly. That doesn't look good, does it? Nobody can read that. It looked better early. Yeah, so I'll talk you through it anyway. So basically, so this is the code. If I run the code, run as Android application. This the emulator I'm using. Any Android programmers here? Okay. The emulator I'm using is something called Genymotion. But there's in Eclipse there's a bug here that it doesn't appear until you, and I haven't found a solution for it. Right. So if anyone has a solution for it, come to me afterwards. I shouldn't? Man, but I'm old school. What do you use for Android? IntelliJ? Right, I'm buying you a beer later. Okay. Okay, so I've got Genymotion here. There we go. Okay. So this is the application itself. So what I'm using, so normally this application itself, I would, in the settings, I would sync it with the Bluetooth source. So if I had the Bluetooth device with me, I would sync it with that. But what I'm using is I'm using a test record, which really is just an ASCII file with the electrical signals that would be coming from the heart. Right? So once we've got that primed, let me go to the cloud part, right? So the cloud part looks a bit like this. So here we have our, I'm going to try and, I'll have to, let me look at the display here. Okay, so so this is, so everybody here has a Bluemix account. Really? Look into my eyes. Don't lie to me. Okay, check it out. It's actually, I've worked for 10 years with IBM. We've produced some pigs of software in our times, but this stuff I think is fantastic. I mean, I really love working with it every day. At the start it had its problems, still has a few problems, but it really is. It's a nice platform to work with. Typically on the top, right, the dashboard, the applications that are running. I don't have time to go through the full interface here. So the application I have running here is something called, this is the application here itself. So this is a Node.js application. And it really is, it's this Node-RED wiring tool. No, I didn't write the application. It's a Node.js application that came from the guys in Horsley. We can see here it's got a URL. And we can see here, so anything that's round is the runtime. And here are the list of services that I subscribed this application to. And that's important because in the Node-RED application, you will see a panel of nodes on the left. And they're actually connected. They will be connected to these services that are running in the application. So we can see here I've got an autoscaling. So autoscaling happens if a lot of traffic is coming to this Node-RED application. It detects when the CPU is at parameters you can set and will automatically add another instance of that Node-RED application. It would add instances up, but it would also remove instances down. Because remember, cloud, you basically pay for what you use. So we have the DashDB, that's the analytics warehouse I spoke about. We have Hadoop as well. I'll just show you an example of that. Cloudant, that's our big bucket for the things. This is the Internet of Things service. That's the MQ infrastructure waiting to receive all of these messages. These were basically two Watson services I was playing with afterwards, but I don't have time to talk about these in the demo. So let's open the application. Okay, so here it is, Node-RED editor. Okay, so this is the Node.js application. Now, on the left, we can see these nodes that you can drag and drop, right? And the first one I've dragged and dropped is this one, right? So this is basically the receiver. And if we open it up, the authentication is going to be the Bluemix service itself. The device type is going to be a heart monitor. The event is going to be called beat, and the format is going to be called JSON. Okay. Now, let me take you to the river. Let me take you to the code. It sounds like the opening line of a song. So this is the actual code itself, right? So okay. Let me run it first. Okay. Sorry, no, I'm jumping from. So the first thing, if you're doing an Internet of Things project, is you want to do a sanity check on your mobile application. You want to basically put one of these debug nodes. So when I run the application, let me run it here. I run the test record, right, and we're off and running, okay? So this is Dan's heart, right? You see it does pause at the first one because what it's doing is sending out a JSON message here. So we can see that the debug is working because the data is coming in here. Okay. So each time there's a beat, I build a JSON message and I'm sending out information like, the longitude and latitude, Let's say the beat starts going to 0, there's no beat, right? It'd be nice to send an ambulance out to find the guy on the golf course or in his girlfriend's apartment. Okay. I forgot this is being filmed. I need to be careful. Okay, so let's just pause that for a second, disconnect. Okay, so what's happening here? Okay, so the messages are coming in. We have this node, which is a debug, just to do a sanity check for us. Then we have Cloudant. So this Cloudant node, if we drag down here, right, on these nodes, we can see on the storage, there's a Cloudant node here. So the simple fact of dragging the Cloudant node in here, if we double click on it, on the service, when we pull it down, we can see here inside this database. That appears on that drop-down list because in our dashboard, we added a Cloudant database here. If we added a second Cloudant database, we would see 2 items on that. So back to Node-RED. So the simple fact, okay, let me delete that. So this is the service. This is the name of the database. Whatever you put in here, if it doesn't exist, it will create a database. If we call that DOR2, it will create a database called DR2 if it doesn't exist. Okay. Then we write to Hadoop. What I do is I create a file name and I write it to Hadoop. And what it does is it appends each time there's a new line, it will write it to a file in Hadoop. Now, I'm not using it in this demo Hadoop, but I just wanted to show you the list of services, that list of nodes basically helps you to take IoT messages in JSON format and helps you to actually send it to different services. So think of this Node-RED as a wiring tool. The second thing I want to do is in the application, we have here, I'm waiting for an event. And if the event is of type chest pain, right, I basically want to send, I want to formulate an SMS message. So here's the new message. Takes the payload, the patient ID. At location, takes the location. Got a chest pain. Okay, and I want to send that. And this is the Twilio service. Okay, so I'm looking for a volunteer. I want a phone number. Can't be a girl because that comes across as a bit creepy. And is that a Danish number? Very good. Plus 45. Let's take that. Let's deploy. Let's all hold hands and pray to the man above or below. Okay, so let's see. We want to send just emergency. I've got a chest pain. Okay, it seems to have gone out successfully. So there should be an SMS going. What did the SMS say to you? Exactly, and you've got the GPS location. So just kind of an example of what we're trying to wire here. Okay, so let's have a look at the Cloudant part here. So no, before we look at the Cloudant part, let's have a look at the piece of code on the client side. Now this was the, and this was the bit at the start that was the most difficult for me, was to actually work out how to actually connect and send the MQTT message. Our documentation wasn't so good on that. So anyone who is looking at writing this in Android and wants to use MQTT to communicate this, I'll give them this source code for a very, very good price. So each time there's a new beat. So let's see, can we zoom in here? Let's make this bigger anyway. Okay. So each time there's a new beat. Let me zoom in there. Did that work? Right. I'm building a JSON object, and I'm taking these values, the average rate of the heartbeat, whether there's things like, if we look at that, PVC, a lot of these terms are quite medical. PVC is, I think, pulmonary ventricular something. It's basically when the 2 bottom chambers of your heart, if they're irregular. I mean, these algorithms I found, a lot of this code I found out in the internet. And there's there's algorithms on the phone that are doing detection of that. So basically, I'm just giving an example here of the location, the longitude, latitude. I'm taking this information, building it into a JSON message, and then I'm calling MQTT. Right, I've built this class to send the beat. So let's have a look at what that looks like. So the first thing, send beat, we do a connection, bless you. The first thing is, okay, the client ID, we get the API key. Okay, now the API key comes from one of the settings in the application itself. This is the API key. Now, this API key in the Internet of Things Foundation service, all of your devices, you associate API keys with them. So that on your client, you have an API key and a token associated with a device. So in the setup of that IoT service, there is a dashboard where you set up your devices. You give them unique device ID keys, and you set up API keys. So you could have multiple keys for a device. So in this example, I'm using the phone number for each patient, and I'm giving them one API key. And that IoT service has a REST-based interface to it as well. So you might have your own portal where each time you're onboarding a new patient, it's automatically creating the keys and assigning them and sending out that information. So when a patient gets gets his heart rate monitor and his phone, he needs to fill in these details, the API key and the authentication token, because this is what's used in the MQTT code. I'm going blind here to do the connection. So this is the connection. Also the organization ID. That each time you create an Internet of Things service, you get an organization ID for that. So the organization ID, messaging, Internet of Things, IBMCloud.com. This is the port it goes out on, 188.83 here. So that's the connection set up the client. Then on the sending the beat, we basically build an MQTT message. This is the topic, IoT-2. I'm not the greatest developer in the world. I mean, all of this, for you young developers out here, this is not an example of the best written code ever. I kind of hacked this together. The ID, the device ID, the fact that it's an event, it's a beat, the format is JSON, and I publish. And then the message, the local MQTT message, has come from here and gets the payload. And the payload really was that JSON message. Now, that piece of code there actually took me about 2 days to work out, Now, I'm not the sharpest tool in the box, but if anyone is trying to use MQTT on an Android phone or any other, an Android phone, come to me, and I will help them with that part. And once you get that part going, the rest, all of the wiring bit at the back end is actually quite easy. Okay, so we have so that's the client side, sending the data. So coming in here, it's listening that it's a beat. The device type is a heart monitor. Let's go back now to. Let me zoom down a bit. Let's go back to the dashboard here. Okay, so on the Internet of Things service. Let's have a quick look at that. Just to show you what the dashboard looks like for that. So launch the dashboard. So we can see, well, you can't see, but on the URL up there, it says, OPTTFS. That's the organizational ID. So each time you have an application and you create an IoT service with it, you will get a new organizational ID. The list of devices I have one device. Call it a heart monitor. The device ID I've given is my phone number. The last event happened 10 minutes ago. Okay, these are the API keys. So the client, I've set up a key and a token, and you need to memorize the token because you'll never see it again. The easiest thing is just to basically create a new token and set it up in the application itself. You can add people who have an IBM ID so that they can see this dashboard. Now, behind all of that Internet of Things service is a whole load of IBM technology. There's IBM message site, so with the click of a button, in 3 minutes, you have all of this infrastructure ready to use for your application. I mean, that's, things have moved on, right? So I think I've explained the same thing to my wife. She didn't seem to be as excited about it as me. I mean, I don't know. Okay, so that's, let's go back. So on the Cloudant part, so let's launch the dashboard for Cloudant. Launch the dashboard. So here we see the databases, okay? So imagine we wanted to create a new database. So let's do a test here, okay? Let's go back to our Node-RED. Let's give it a new name, right? Okay, so I can see the operation is insert, only store the payload, okay, deploy. Now, so if I run the application again, okay, first beat comes in, we can see the messages here in the debug pane of Node-RED. So now we see, are these records going into Cloudant? So where have we got our Cloudant? So okay, so on the databases, nothing. So let's do a refresh. Let's bring up this page again. Okay, there we go. So we see a new database has been created here. There's a whole load of documents. Let's edit one of the documents. So we can see here, so we can see that data is going in there. Now what I've done here then is on Cloudant, so that's going into Cloudant. The next thing I wanted to do was, let's pause that. I want to do the back-end analytics part. Now, the back-end analytics part, the bit I found was something called, is based on something that cardiologists use, and it's called heart rate variability. So over 24 hours, the distance, the average distance between the times that you have a correct QRS signal, that variation, using a lot of mathematics, basically tells you how healthy your body is. I went through chapter 1 of reading it and I fell asleep. But it's, what I'm using is, I'm using something called Azure Studio, which was acquired by Microsoft, which breaks my heart because, I mean, we should have acquired them. So this is the main part here. I'm basically connecting to DashDB. Now in DashDB, let me launch that DashDB. So let's go back to where are we here? Find. Look at our console again. So let's look at our dashboard. So if we look at our, this is our analytics warehouse. And if we launch. So I'm using Cloudant as the big bucket, just basically to store everything. Then I'm using DashDB as the data warehouse, which afterwards I'm connecting with R, but later I can connect with SPSS, later I connect with some other analytics tools. So I'm using these different back-end elements to try and, so on the manage, we have something called sync from Cloudant. So I'm getting this data warehouse to sync with Cloudant. And that bit sometimes can be a little bit tricky. It's just getting the URL here. So these credentials here on the left, you basically get them from the credentials from Cloudant. But the end result is that it's actually it's creating an SQL type SQL tables with I've cut down a version to create basically SQL tables, which I then use to connect to with R. So and that's the bit there. So just using a JDBC connection. This is the URL for it, BlueDB. That's the username, right? And the password. Once again, not great code. Young programmers never have your password in a piece of code, but anyway. Then I'm doing a query, select the location, the HR mean, whatever from it. Okay. So if I run this, okay, let's say stop the application. If I run it, okay, now I'm not going to win any awards for design either. But this is connecting to it, and it's it's using some of the old device IDs, some of the heart rate means, the location. This is on the device, the patient records, the ECG itself. So every hour as well, what I was doing is I was taking an hour's worth of data, the actual data, and sending that across as a file and storing it. So we can. Then there's things called, and this is where it gets. This is where the cardiologist comes in, right? I can't even pronounce this, and I've had no beer. Non-interpolated instantaneous heartbeat rate. Now that means something to a physician, a cardiologist, or looking at this on one patient, they can start to build a profile. I mean, behind this are things like fast Fourier transforms, where they're doing signal processing behind it, and all of this I got from that open source package, that our HRV package. This is computing all of this again, and this is the analytics part. Now we're working with the SPSS guys to come up with more models and more predictive models. So this is a work in progress. This is where it is at the moment. I hope it was of some benefit. The final thing is the map of devices. So we can see. So we've some of our colleagues running it here. Other guys in Ireland down here. Okay. So let me go back to the presentation, and it'll be done fairly soon. So we did examine the code. So a quick wrap up. What I was trying to show was Internet of Things, mobile device, MQTT on it, some algorithms happening on the phone, but the main thing was taking a snapshot of a heartbeat and some data, sending it then back to the back end, to this magic powerhouse run by IBM, where we have all this infrastructure in place. We have IBM engineers working 24/7 to keep the lights on all of this, on this cloud, with all of this analytics software in the background. So the first thing that we have is the MQ infrastructure ready to take all of these events. Imagine thousands of devices sending all of these messages. So that's the first part, having enough infrastructure to handle that amount of traffic. Then afterwards, we need a big bucket, a big database. So we're using Cloudant. Then afterwards, we need, we want to develop the analytics. So after that, I'm syncing it into a data warehouse. And then afterwards, you can do what you want. Plug in different analytics, do historical analysis. Because the way I see healthcare going is you go into the doctor and you have a problem with your heart. Now, the doctor has a full profile on you. He has your family history. He has, potentially he will have, your genetic makeup. So I'm looking at healthcare. You buy a brand new BMW, it has a very sophisticated engine management system in it. I'm looking at healthcare in the next couple of years, where we will have devices monitoring it, not just a Fitbit to see how much you're walking, but real stuff monitoring your heart, your blood sugar levels. And as the technology gets better, combining all of that data, combining it with your family history, combining it with, medical data from, let's say, all the Danish people, all the Irish people, they have they may have different lifestyles. Combining all of that big data, and then basically doing predictive analysis on human beings. So that's where I see all of this going. So I think it's a very, very exciting time. I think healthcare will lead the way, and I think this is an exciting platform. Okay, thank you.